Okay, hello. Okay, it's Mr. Kobe again. I hope everyone is doing great. So today's lesson we'll be doing a tutorial session based on this question. So it's one of the question I took from I think it was on examination September 2021. I think it's for preparatory. So I wanted to try this question today. It comes like this. 3-meter sphere X, you see X over here, and Y and Z carry charges are placed on the vertices of the right-handly triangle as shown below. I hope you can see all those things, okay? So now here there is, in this sphere right here, there is a charge, and over here there is also a charge, and over here there is also a charge. Then we have a distance of 3. You can say, if you like, you can say this one it's 3 centimeters, and also here it's also 6 centimeters from here to here. Okay, so now the first question comes like this. It says state Coulomb's law in words. So I'll write this down, but please make sure before you go to an exam you know how to do these definitions, because they will be asking you. It's 2 marks for nothing. It's 2 marks for nothing. Comes like this. Coulomb's law. It's Coulomb's law. It says the magnitude forces, the magnitude force exert by 1 point charge, which is Q1 on another point charge, which is what? Which is your charge 2. I'll write a sample here, which is like F equals to K, charge 1, charge 2 over your R squared. So now the magnitude force exerted by 1 point charge on another point charge, Q1, Q2, is what? Is directly proportional, proportional okay, I think it's good. Proportional to the product of the charges and inversely, which means the moment the distance becomes smaller, the force increases, which means that when distance is big, when a distance is so big, the force would be less, but when a distance is so small, expect the force to be greater. Okay, so and inversely proportional to the square of distance between them. Okay, now that's the definition you need to know. So once you know to state Coulomb's law, you are sorted. Okay, let's go to the next question. Okay, so if you want to write this down, you can pause the video and then try to write the definition. Okay, comes the next question. It comes like this. Okay, it says calculate the magnitude of the net force or net electrostatic force on sphere B. I hope you can see sphere B over here. This is your sphere B. Okay, so what you need to do is to draw something called a vector diagram. So how are you going to do that thing? It's so easy. Okay, I would like to erase this part so that I will actually have more space to do everything. I hope you have take some notes on that. But if you have a problem, it's so simple. Download the exam guide after downloading the exam guide, and then you would try you will find all these definitions of columns below. Okay, the next question comes like this. Calculate the magnitude of the net force. Okay, so I want you to draw something called a vector diagram on sphere B. Okay, so how are you going to do that? So simple. Okay, this is a positive charge and it's a positive charge. So what type of force happening between the two? It's a repulsion force. So when these exert a force on these, it will force these to go downward, which means the first thing you can do, there is going to be a force acting downward between where? It's a force between Y and Z. There will be that repulsion force going downward. And then between the two, X and Z, then this is positive, and then this is what? This is negative. So there will be an attraction, which means there will be force of attraction on Z attracted to one, to X. So simple. You're going to draw that thing. Okay, my drawing, hope it will be a bit straight. So in this direction, this is a force between where? Between X and your Z. Okay, it's Z and it's Z. Okay, so after that, don't forget the angle here. So there is an angle of 60. Then you're going to construct something, your vertical. I'm going to explain why you're doing this thing. Okay, then the angle here, it's what? They told you it's 60. Okay, and you're also going to construct your what? Your horizontal, which means the angle here should be what? Let me use another mark. Okay, the angle here should be 30. Okay, should be 30. The angle over there. Okay, so once you draw that, the next thing you want to do, you want to try to calculate the net. So in something that is a right-handed triangle, normally in maths, we use r squared equals to x squared plus your y squared. We normally use the Pythagoras theorem. So in this type of question, try to get all your horizontal, which means we need to get all the horizontal forces and get all your vertical forces. Then when you're done, you put them here and here. Then you try to get your resultant force. As they told us, they said they want the net force or the resultant force. So once you're done constructing this, it's up to you which diagram you actually want to be working with. If you want to work with the angle 60, which means you'll be working with this diagram. But I will choose this diagram over here. Let me show you which one I'm going to use. I'm going to use this diagram over here, the angle of theta. So if I draw it, it will be something like this, okay? Now I know the force is acting in this direction. My horizontal, because this thing is attracting these things to move in this direction. And you're going to have what? And it's also my vertical force will point upward. Okay, which means if I'm calculating the force here, it's going to be pointing upward. Now this is my F, X, Z, and it's my Y component. Now this is my F, X, Z, and then this is my X, or my horizontal component. Okay, now you go back to the calculation aside. So when you do the calculations, you're going to start doing by what? It's up to you. Now you can start here by calculating the force between the two. It's going to be the vertical but downward force. Okay, so it's up to you. But maybe you can also start by doing the force, calculating the force on XZ, Let's start by that one. That's your step number one. You're going to say, okay, let me erase this part. Okay, you're going to say your F, okay, let me use the black mark for you. Okay, so you're going to say the force between your X and your Z is equals to K charge 1 charge 2 over your R squared. So once you're done with that, you're going to do it like what? You're going to say, okay, it's always a constant, 9 times 10 raised power 9, okay? Charge Q1. Q1 here, I'm going to make my what? My X, which means this would be your X. And therefore, you're going to say it's going to be 2.1 is 2.1 times 10 raised negative 6. And therefore, my Q2 is going to be what? It's going to be my 1.8. 1.8 times 10 raised negative 6. And over the distance is 6, okay? Distance is 6 centimeter. It's going to be 6 times 10 raised negative 2, what? Negative 2, then you're going to put the squared. So when you do the calculations here, you're going to get that the force between x and y, that force of attraction, is going to be 9,45 newtons when you do your calculations. Now you can write attraction as a force or a direction. It's going to be attracted. Okay, once you're done with that, you're going to go to where? A force between y, which means now we know the value here. Now we know the value here. This force is what? It's 9,45 newton. Okay, so if you're done, you're going to do the same thing between y. Okay, let me take the question. Between y and z, you're going to say your F equals to K, charge 1. This one is between y and your z, Q2 over the distance, which is your r squared. Okay, you're going to do what? You're going to say, you can write it here, you can write it below. Okay, it's going to be, your K is a constant, 9 times 10 raised power 9. Charge 1, in this case, is going to be your 1.5 times 10 raised negative 6. And then your second charge, which is your Z, and your Z here, when you check on the diagram, it's 1.8, 1.8 times 10 raised negative 6. Okay, sorry about this one, sorry about that. Okay, and then you're going to close here, then over the distance is distance was given, it was 3 times 10 raised negative 2, or 3 centimeters. 3 times 10 raised negative 2, then you're going to put the square. So when you punch your calculator, okay, when you punch your calculator, you're going to get the force is it's going to be 27 newton, which means now we know here the force over here is 27 newton, which means that is the force of what? Of repulsion. Okay, so now you are sorted. You know the force from here, which is 9,45, and the force here is 27 newton. So what's your next thing? Try to get the horizontal and try to get the vertical. That's so easy. I'm gonna be working with the handle of 30. Okay, I won't take this diagram of 60. I want to work with something that I can see on a horizontal level. Okay, allow me to erase this part. I hope you've took some notes, and if you haven't, please try to pause the video and take this notes. My space is so small. Okay, so let me erase this part over here. Okay, so after that, now once you have these forces, try to get what? The horizontal, your x and what? And your y. Okay, now let's try to get my fx set, which is your vertical component. So your f x z, this one, which is your y. Okay, we're trying to get the y component. I'm trying to get what? The vertical component. So when you check here, it's given the opposite trig ratio, which is that one. Opposite over hypotenuse is what? Now we know, because now our hypotenuse is what? Is in this case is going to be 9,45. Now we have the hypotenuse, then we have this opposite, which that trig ratio, it's sine, exactly. So once you know it's sine, it's going to say sine of angle 30, okay, equals to your y. What is y? Your y in this case is what? Your y, you're looking for that, which is your fx, your y, over your hypotenuse. What is your hypotenuse? Is 9,45. Then you're going to cross multiply. You're going to find that your fx z y is equals to, you should get, when you type your calculator, you should get roughly the number, which is 4,725 newton, which means now we know the value over here. What's the value over here on our vertical? It's going to be 4,725. Now this thing is acting where? Upward. You see, which means now we have a force here, which is 9,4. Sorry, it's 4, sorry. It's going to be 4,725. The force over here and the force over here is the same. Okay, it's the same. So once you're done with that thing, then your next thing, what you want to do, you want to work with your horizontal, your f, x, z, and it's your x. Okay, now this is the first one over here. This is for the first one over here. Okay, acting upward. Now I'm trying to get this one which is acting to the left. Okay, so for that one, I'm going to do what? It's so simple. You're going to do the same thing. You're going to check it's adjusting here to an angle. So it's cos. Cos of angle 30 equals to, and therefore when you check your what is going to be x over your hypotenuse. So your x is what is going to be your f xz, which is your sorry about this one. Sorry, it should be f. It should be what? It should be f. This one we're checking over here. F y. Just go back to the diagram. It's f x z, f x z, and it's your what? It's your x component. We're trying to check our x component, which is over our hypotenuse, which is 9,45. So when you do the calculation, you're going to cross multiply. You're going to get that your fxz, which is your x component, is going to give you the value of it should be 8,1. It should be 8,183. Then you're going to write Newton, where this thing is acting direction to the left, which means now we know the component. This one, it's 8,183, and it's, we're going to write it down here, 8,183. Okay, I hope you understand that part. So once you're getting all your horizontal and all your vertical, the next thing, gets the net horizontal. Get the net horizontal. Okay, let's go back to our diagram. You're going to get all the net horizontal, okay, and try to get all the net vertical. Okay, please allow me to erase this part. I hope you have took some notes. This one is for the second part. For the first part, this for the vertical, this for the horizontal, for the force or the net x for the force x z. Okay, so once you took some note, okay, let's go to the second part. Let's try to get, because we want to get the net. So our f net is equal to, let's put the squared, because I'll be referring to what? To r squared equals to x. Sorry, let me write this down over here. Okay, so our r squared equal to x squared plus y squared. So I'll be referring to that Pythagoras theorem rule. Okay, so what I'm going to do, I will be saying for my resultant on z, remember your net force on z now is going to be your f net squared equals to what? Your f net x. Okay, for the x, we then put the squared plus your f net y, which is your vertical. Okay, which means when you're done, you're gonna go back to this one. You're gonna be doing this. You're gonna say your f net, let's take this one, squared is equals to. So when you check your x, for x, we only have one force. What is that force? Which is 8,183. And it's acting to the left. You can put the negative sign, which means it's going to the left is negative. It's negative 8,183. Then put the square. Plus, for your vertical, on your vertical, when you check here, we have two. We have this one, 27, and then we have also that one, which is 4,725. Okay, which means it's going to be negative because downward is positive. It's up to you. If I choose downward is positive, you can also do that. Okay, it's up to you which direction you want to choose. If you want to choose downward is positive, you want to write 27. Here is positive. So it's up to you which one you want to choose. It's going to be 27 plus upward, which is 4,205, then put the square. Then after that, you're going to take the square root both sides. Going to take the square root and take the square root, then which means your f net, if you punch all this in your calculator, you should get the net force, which is 23,73 Newton. Now that becomes the net force experienced by x and y on z. I hope that was 8 marks. You know, that was a simple 8 marks. Now after that, let's try to go to the and if you want the angle, how are you going to approach this thing? If you want the angle, sorry, here it's supposed 4,2. Sorry, here I think I've made the mistake here. It's supposed to be 4,7 to 5 exactly. So this one, which means it's your y, is going to be in the opposite direction. Okay, but when you punch your calculator, you should get 23,73. Now the next thing, when I go to 7.2, now when you check your 7.2, they say two identical sphere A and B carrying a charge 5 microcoulomb and 10 microcoulomb respectively are separated by a distance 30 which is what? It's 30 millimeter and 15. Sorry, by a distance of 30 millimeter. P is a point located at distance of 15 millimeter. Sphere B is shown below, which means you can see the diagram. This one from point P is 50 millimeters. Then this one, they are 30 millimeters separated. Okay, now the sphere A and B, it's A and B, are allowed to touch each other and then return to the original position, which means they were allowed to touch each other and then return to the original position. They touch, then separated. Okay, now the first question says, define electric field at a point. They want you to define the electric field at a point. So how are you going to define that? So it's so easy. Okay, so electric field at a point. Okay, we are done with this question. If in this question, if you want the end, you're gonna take second function tan of your y, which is this one, and over your x, and then you're gonna take the second function of that thing, then you're gonna get the end. For example, it's going to be tan theta equals to negative 27 plus 4,725 over 8 comma negative 8 comma 183. Then the end you're going to get here is going to be your direction if you want the direction. So about that. Now let's go to the second question, which is this part. It says define the electric field at a point. So how are you going to define the electric field at a point? It's so simple. Now the electric, okay, can I just draw over here? The electric field at a point is the electrostatic force experience per unit a positive charge placed at that point. Okay, now this is the definition of the electric field at a point. Okay, so if you know this thing, okay, you can pause the video and try to take some notes. But if you don't have time for that, you can just download the exam guide for grade 12. You're going to get all this definition. Now the next thing, 7.2.2, draw the electric field pattern between sphere A and B after touching. So when I give you the hint, if two spheres were brought into contact and then separated, remember this, they will both have the same charge. Okay, so which means your step number 1, try to calculate the new charge. Please allow me to erase this part. Okay, thank you. Okay, so what you're gonna do, so simple, you're gonna say Q new, okay, trying to get what is the new charge on your sphere after they have been separated. It's going to be Q1 plus Q2 over 2. So it's going to be what? Now, when you check here, sphere A has a charge of 5 microcoulomb. It's going to be 5 plus, then sphere B have negative 10. Okay, so I haven't put the numbers. I'm going to explain why. It's because it's microcoulomb and same is microcoulomb over 2. Then you're going to get the number of the charge on each sphere. You should get the value of negative 2,5 microcoulomb. Okay, microcoulomb, which means when you draw the electric field, it's going to look like this. Sorry, it's going to be sphere A. Let me erase this part. So you know now they were both negative. So negative field, they're pointing to what? Okay, so you're gonna have something like this. Okay, let me draw it over here. You're gonna have the sphere and the sphere. Now it's A and it's B. So when you draw them, okay, it's going to be something like this. Okay, it's going to be something like this. Okay, but they will never touch it. Make sure they don't cross, okay? Make sure they don't cross. As long as they are pointing away, okay? I'm going to put the arrows, okay? Something like this. Since they are both negative, you're going to point the arrows toward. So if you draw something like this, you are in the right direction, okay? So they are pointing toward, okay? So in this part, they all be pointing toward like this, okay? So they will be pointing toward, okay? So I hope you can see. Now this would be what? The answer for 7.2.2. Now the last question, it says, calculate the magnitude of the net electric field at point P. So now at point P, I think that it's so easy, okay? We're going to do it right now then before we run out of time, okay? So how are we going to do that? I think it's also the easiest question. So to get the net electric field, which means you need to work with, you're going to use the formula. It's so simple because you're going to be dealing with the electric field at a certain point. And when you check this diagram, they are saying at this point, and we know the charge, and we know what? We know exactly the distance. But now this one is after separation. Okay, can I erase this part? Thank you. So now we know the charge now on each sphere. A has a charge of negative 2.5 times 10 raised negative 6. Same goes to what? To B has what? A charge of negative 2.5 times 10 raised negative 6. Column, okay? So once you're done with that, you're going to use the formula. E equals to K, charge 1, over R squared equal to, K is always a constant, 9 times 10 raised power 9. Charge it's 2.5 times 10 raised negative 6 over the distance. When you check the distance here, now we're talking about A. From here to here is what? The 80 plus 15 is 45 exactly. So it's going to be 45 times 10 raised negative 3. Why I'm doing that is because it's in millimeters, converting to meters. Then put the squared. Then you're going to get that the answer you should get, it should be 1,11 times 10 raised 7. Then Newton per coulomb. Okay? You can say to the left. Why to the left? Okay, I'll explain why. We're going to use something. When you determine the direction of the electric field, you use something called a positive test charge. So when you put the positive test charge here and it's negative, it's going to be attracted to the left. That tells you the direction. Okay, now after that, you're done. If you're done with this one, you're going to do the second one. Now this one is for what? It's for A. Now let's do for B. B, it's E equals to K, charge 1. I'm thinking about Coulomb's law, sorry. Okay, R squared equal to 9 times 10 raised power 9. Then the charge here, it's what? It's still the same. It's 2.5 times 10 raised negative 6. Oh, what's the distance? When you check the distance from here to here, it's 15 millimeters. 15 times 10 raised negative 3. That's how you convert the millimeters to meters. Divide by 1,000, put the squared. You're going to get the number of what, which is 1,00 times 10. This is my times 10, okay? Times 10 raised power 8 Newton per coulomb. Okay, now same thing left. Okay, sorry about that. I hope you cannot see this part, but it's as said here, left. I'm going to write it here in my space. It's so small. Left. Okay, that's the direction. That's the direction. Okay, now let's go to the next one. Okay, so now the last part, we need to get the net electric field. So your E net, since they're both pointing in the same direction, you're going to add them. It's going to be what? You just add them. E net is equal to this one plus this one. 1,11 times 10 raised 7 plus 1,00 times 10 raised power 8. Then you're going to get that the answer is 1,11 times 10 raised power 8 Newton per coulomb. Then the direction, it's left because it's going in to the left. So now that's all about this question over here. It was 21 marks. You see how easy it is, just 21 marks. I hope everything was understood. So I'm done with this part. So again, if you have any question regarding or relating to any physical science question, please just simply email me on happy. This is my email, okay? It's happy. Okay, you cannot see this part. Okay, let me erase this part over here. It's going to be my cell phone number 071-2768072, or you can simply email me happy, all small numbers. It's happy said 157 at gmail.com, or you can send your question over here. I'm gonna create the online pages so that you can follow us. So it's Mr. Club over here. Thank you so much for working with me, and you stay with me until this time. Okay, so for now, it's Boss Move Academy signing out. Thank you.